Hey guys, this is Mr. Jameson. Thank you for watching this video since I will not be able to be in class on Monday. So today we're going to be looking at transformations, being able to graph a parent function that has been transformed. So what are parent functions? So parent functions are basically like the basic graphs that we need to memorize. We have the identity function, the squaring function, and the reciprocal function. So like y equals x squared, and y equals 1 over x. And so the shape of these should be memorized. Know that y equals x is an odd function, y equals, or f of x equals x squared is an even function, and y equals 1 over x is an odd function. It's symmetric about the origin. Four more parent functions are the square root function. It is not symmetric about anything. It's neither odd nor even. The cubed root function, it is symmetric about the origin. The absolute value function, we looked at that on Thursday/Friday. This one is symmetric about the y-axis, so it's even. And the cubic function, symmetric about the origin, so that is odd. And it has a cubed root, an odd power. Okay, so those are the 7 parent functions that we are going to be using and transforming today. So where last time we only had one, the absolute value function, now we're going to be transforming all of these different ones. So we're first going to start off with f of x equals x squared. And these are the different types of transformations that we're going to be doing. Reflections, vertical shifts, horizontal shifts, vertical stretch and shrink, and horizontal stretch and shrink. Okay, so first off with the reflections. There are 2 types of reflections that can transform a graph, across the x-axis and across the y-axis. So, making sure I have all my notes correctly. Boop. Also, this is the first time that I'm using the video with this program, so it might take me a few extra moments to get used to everything. So when we have y equals negative x squared, where the negative is inside the parentheses, then that is a reflection across the y-axis. It's a reflection across the y-axis. Oops, y-axis. When we have y equals negative and then x squared, that is a reflection across the x-axis. X-axis. Okay, and so we'll do some problems with that in a minute. Okay, so given below, determine the type of reflection given. So example, f of x equals the square root of x is the parent function, the one that starts it all. And then we have f of x equals negative the square root of x. So having f of x equal negative the square root of x, that is a transformation over the y-axis, over the x-axis. So it would look like, so if we have our axes, it would look like this. Okay? Because it's being reflected over the x-axis. For this one, it's being reflected over the y-axis, so it would look something like, oops, having our x and our y, it would look like this. Very general sketch. Obviously, that is not really accurate. Okay. So outside reflects over the x-axis, inside reflects over the y-axis. I would say we're going to see more of this, more reflecting over the x-axis than this one, but both of them happen. Next, the next type of transformations are shifts. So we have vertical shifts. We have vertical shifts where we have f of x and we add something to that function, if we add or subtract. So here our parent function is f of x equals x squared. And then if we shift it up 3, f of x equals x squared plus 3. So what do you guys think if we shifted it down 2? F of x would equal x squared what? X squared minus 2. Because it shifted down 2. So see here, the vertex was 0, 0. And if we shift up 3, the vertex is 0, 3. And if we shift down 2, the vertex is 0, negative 2. For horizontal shift, it shifts left and right. So it's f of x plus or minus h. So that plus or minus happens inside the parentheses. It's important to note when things happen inside the parentheses and when things happen outside, or operations happen outside of the parentheses. So we denote it as h. So we have f of x equals x squared. The blue one is y equals x plus 2. This is because when it's the opposite. So it's kind of like x minus h. So if we see a plus 2, it's more like negative 2, or the opposite of negative 2. So this is kind of like x minus negative h squared. So this point is, the vertex is at negative 2, 0. Whereas for here, x minus 2, quantity squared, the point is at 2, 0. It's shifting to the right 2. So you might be asking yourself, why do we use the letters H and K? It's simply because they're not used in other places very often in math. And so we use it for transformations and for the center of circles, like sort of the center of circles and in conics. So combining a vertical and horizontal shift. So here's an example of a function that is shifted down 4 units and to the right 6 units from the original function. So in green, we have our parent function of f of x equals the absolute value of x. And then here we can see it was shifted to the right 6 and down 4. To the right 6 and down 4. So that we have a vertex at 6, comma, negative 4. So h equals 6 and k equals negative 4. So that our vertex is at 6, negative 4. So now let's write an equation for a function that has a graph with the following with the given characteristics. Check your answers using a graphing calculator. So please pause the video, read the examples, and then please start playing the video again. So here are our answers. So being upside down means that it's reflected over the x-axis, so the negative is outside the parentheses, and shifted to the right 5. So it's going to be x minus 5, meaning h is 5, and so it needs to be inside the parentheses. And then here are the solutions for the other ones. So the fourth type of transformation is called a vertical stretch and a shrink. So, and we use the letter A to represent this. And this is the number that comes, it's the coefficient of the parent function. So here we have y equals x squared. And if the absolute value of A is greater than 1, then it's a stretch. So see here, with y equals 4x squared, it's kind of stretched more vertically. So y equals x squared, and then y equals 4x squared gets stretched a little bit. Whereas y equals 1/4 x squared gets a little shrink. It gets flattened a little bit. And so this affects the how much it gets stretched up or shrunk in the vertical direction. So the fifth transformation is horizontal stretch and shrink. So this is y equals f of b times x. So here, when we have y equals 4x squared, if we look at it horizontally, it's kind of it's shrinking horizontally. Where we have y equals 1/4 x squared, it's being stretched horizontally. And you're probably wondering, it looks awfully similar to the ones right here, and that's true. So a horizontal shrink is the same thing as a vertical stretch, and a horizontal stretch is the same thing as a vertical shrink. Okay, so let's start combining some of these. And to kind of give you guys a little bit of a sense, we have f of x equals a. So I'm just going to use the absolute value function. So absolute value of bx minus h plus k. All right, so where a affects the vertical shrink and stretch and whether it is reflected over the y-axis or x-axis or not. B affects the horizontal shrink or stretch and determines whether it is reflected over the y-axis or not. H shifts it right, and K shifts it right and left, and K shifts it up and down. All right, so here we have the absolute value of x minus 3 minus 4. So h equals 3, k equals negative 4. A equals 1, and b equals 1, so we don't really have to worry about them. So it looks like it is translated, still working on my handwriting, that's not on paper, translated 3 to the right, and 4 down. Okay, so here we have A, B, H, and K. So A is 1, B is negative 1, H is 0, and K is negative 5. So we have reflection across the reflection across the y-axis, and and we're starting off with x cubed. So x cubed is reflected across the x-axis, while the y-axis and shifted or translated down 5. Okay, and this last one, this g of x, we have a lot of things going on. So a equals negative 3, b equals 1, so no changes with the b. H equals 3, and k equals 5. So we have, x squared is not only reflected across the x-axis, x-axis. There's a vertical stretch of 3. That's an of. And it's translated to the right 3. Oops, to the. And up 5. Okay. So the key things here are identifying A, B, H, and K. And then here's just the review. So if we have a negative A, it reflects across the x-axis. If we have a negative B, it reflects across the y-axis. H has a horizontal shift. K has a vertical shift. A can stretch or shrink vertically, and B can stretch or shrink horizontally. All right, with that we have concluded all of the information that you need to be successful on the Unit 1 test. So now you're going to do an activity to help you start preparing for it.